Hi again, it's me. 5th and 6th grade, this is your science video for Thursday, February 4th. It is pages 135, 136 in your work text study guide of things that we've already talked about. Number 1 through 4 are the first 4 blanks there on first page 135. Lightning changes some of the nitrogen in the air into usable compounds. Rain carries these compounds out of the earth. Bacteria in the blank. Nodules on plants also change nitrogen into compounds. Consumers get nitrogen compounds by eating other animals or blanks. The remains of dead plants and animals are broken down by blanks, and the nitrogen compounds return to the soil. Bacteria releases some nitrogen back into the blank, and the cycle begins again. And so this is a different diagram of the of cycles that you have. The other one was the carbon cycle. This one is the nitrogen cycle. Both of these elements are very important for life on Earth. But this is a study guide, things that you've already read and answered, and then on the back you have some questions to answer about the water cycle. And I think you will have no problem. Tomorrow we'll have an experiment using decomposers, and you're going to each have your own little thing that rots away, okay? And it's not going to smell good, I can tell you that much, but we'll keep them here at school somewhere, probably on your desks. Trying to think if that's a good thing to do. It's only going to be starting this week, and it ends the week after next. Oh, but Matthew won't be here, will he? I forgot about that. That's all right. We're still going to do it anyway. So we'll have to let you observe as much as you can until you leave. All right, so go back to page number 198 in your book, and that's where we're going to start reading, and you'll see some of these answers that are right here on this front page to begin with. Nitrogen cycle. The nitrogen cycle is also an important process. Like carbon, nitrogen is essential to life. In air, who in here knows what's the percentage of oxygen in air that we need? Yes. Yes. Now, close, 21% oxygen. Nitrogen is something 70-something percent that you need in the air. And so that actually becomes a very important part of what we do. So it says, like carbon, nitrogen is essential to life. Without it, living things could not grow and function normally. Nitrogen gas is part of the air that we breathe. In fact, the air is mostly made up of nitrogen gas. However, plants, animals, and people cannot use nitrogen in this form. To be usable, nitrogen gas must combine with other elements. One way nitrogen can change into a usable form is by lightning. Lightning causes nitrogen gas to combine with oxygen. Rain then carries these compounds of nitrogen and oxygen down to the earth. Lightning can change only a small amount of nitrogen at a time. Most nitrogen is changed by bacteria. Many kinds of nitrogen-changing bacteria are found in the soil. They live in little nodules or bumps on the roots of plants, such as peanuts, peas, and beans. The tiny bacteria absorb nitrogen gas from the soil and combine it with other gases to form nitrogen compounds. These compounds help plants to grow. The plants, in turn, provide a habitat for these helpful bacteria. So if you go back to page 135, you will see. So it says lightning changes. So bacteria in the blank nodules. What is the answer there? What's the answer? What'd you guys get? You guys aren't doing this with me while you're listening? So you're just going to listen and not do it and then just write the word down, huh? Go ahead, what? Little nodules, yes, little nodules. On plants also change nitrogen into compounds. Consumers get nitrogen compounds by eating other animals or, well, we haven't gotten there yet, but it is going to be plants, yes. So look at the next page. It says, plants use the nitrogen compounds both to grow and to make proteins. Animals get the proteins and nitrogen by eating the plants or other animals. In this way, animals get a form of nitrogen they can use. When plants and animals die, other kinds of bacteria act as decomposers. These bacteria form compounds from nitrogen and other gases. These compounds are used by some plants. Some of the compounds are broken down completely to form nitrogen gas. This returns nitrogen gas to the air so that the cycle can begin again. All right, and so where does bacteria release the nitrogen back into? Where does it release the nitrogen back into? The air, that's right. All right, and then we have 2 more pages to do here. Water cycle, this next one. Water is always moving between the atmosphere and the earth. The sun warms bodies of water, such as oceans, lakes, and rivers. This heats the water and causes some of it to evaporate. Evaporation is the process of liquid water changing into a vapor or gas. And so you see here, answer number 7, when the sun warms the earth and its water, some of the water changes from liquid water to water vapor. This is called, everybody? No, try again. Yes, you only had a 50-50 chance and you blew it. Okay. Plants, animals, and humans also release water vapor into the air. Plant roots. Oh, stop. You are in my projection area. Are you looking for your paper?
Yes.
Did you find it?
No.
Oh, too bad. Okay.
I need this.
Quiet, please. Okay. Plant roots absorb water from the soil. The water is then carried to the stems and leaves. Tiny openings called stomata and called your secret word allow, stomata is your secret word, and allow water vapor to move out of the plant. This is called transpiration. Animals and humans also breathe out water vapor when they exhale. As water vapor rises high above the earth, it cools. The cooling causes it to change back to liquid. The process of water vapor changing to liquid, that's where condensation comes in, is called condensation. Rain droplets form from condensation. The droplets collect in the clouds and then fall to the earth as precipitation. Some precipitation soaks into the ground and is stored there. This water is known as groundwater. It provides water for plants, streams, rivers, and oceans. Water that does not soak into the ground collects on the earth's surface. This collected water may be as small as a puddle or as large as an ocean. Evaporation of some of this water begins the cycle again. All right, before we get to God's perfect plan, let's look at the creation corner there. It says, you may be surprised to see that all the benefits that God has provided for us in a single tree. A tree absorbs and uses carbon dioxide and then releases oxygen. However, through its leaves and trunk, the tree also absorbs some of the excess carbon dioxide and other gases that are harmful to life. Even a tree's roots are useful. They help filter and clean groundwater. A tree may also change the temperature around it. For example, a single average-sized oak tree not only provides shade from the sun to lower the temperature, it also transpires a lot of water. In fact, it can transpire as much as 375 liters or 95 gallons of water each day. Just like evaporation, transpiration helps cool the tree and the air around it. And of course, the tree provides beauty for us and a habitat for animals. A tree shows how God's creation can be both beautiful and useful. Sometimes you can even build a tree house in it, and you can put more of the animals that are little kids in there and have them stay there. All right, God's perfect plan. It says, our world did not begin by chance. Our great creator planned and created every detail. He planned for each cycle to depend on the other cycles. Water is needed for the water cycle. Water is also used in the carbon cycle during photosynthesis. Nitrogen compounds are made available to plants through precipitation and by being dissolved in groundwater. Seasonal changes also affect other cycles. Autumn leaves fall to the ground. Bacteria break down the leaves to form nitrogen compounds, adding many nutrients to the soil. Plants need these nutrients so that they can grow. During the spring, plants grow and produce new leaves. The leaves are needed for photosynthesis to occur. Through these cycles, God is continually providing for what He has created. All right, as I said, tomorrow we'll be doing an experiment, and so have a good day. We'll see you tomorrow.